Hello curious minds, I'm Maxcer and welcome back to the Ant Network. Today I'm going to show you how to make your very own laboratory style ant nests. These were originally designed by my mentor, world-renowned insect keeper Ray Mendez. If you've seen ants on display at institutions like the San Diego Zoo or the Smithsonian, chances are you've seen Ray's ants, many of which were raised in Petri dish nests just like the ones we're going to make today. This Petri dish nest design is modular and easy to use. The simple hydration system ensures that you can maintain the humidity in the nest, which is necessary for most ant species to thrive in captivity. The dish nests allow for better temperature control than test tubes, and by connecting two together, you can provide the ants with a warm and cool nesting environment. To create this Formicarium, you'll need the following: deep plastic Petri dishes, hydrostone or hydrocal plaster, tube connectors, silicone or vinyl tubing, a boring tool, glue, and distilled water. A full list of materials used is in the video description. Let's get started. If you are a young ant enthusiast, ask an adult to help you with this project. Place the dish on top of a ruler and find the center. Mark both sides about 8 millimeters from the bottom. These will become the hydration ports. Next, rotate the dish 90 degrees and make a mark 10 millimeters from the top. This will be the tubing port. There are multiple ways to bore holes in thin polystyrene plastic. We prefer the cork borer method. To do this, heat the end of a cork borer with a torch or gas stovetop. Line the tube up with the mark and push it firmly through the plastic. If it does not melt through quickly, the tube isn't hot enough. Make sure to use the correct borer for the tubing you have selected. You can also use the metal tip of a hot glue gun to melt through the plastic. Alternatively, heating a screwdriver can also work. The goal here is to get an even hole in the brittle plastic. If you are using thicker Petri dishes, you may be able to drill holes using a hand drill and step bits. The plastic may crack if you apply too much pressure. Remove any excess plastic from the dish. Run a silicone or vinyl tube between the hydration port holes. It should fit snugly. We will need to make 2 batches of hydrostone. For the first batch, we only need to cover a portion of the bottom. This layer will prevent the tube from touching the bottom of the dish, which may compromise the functionality of the hydration system. Mix the hydrostone with a spoon or use an electric mixer for better results. Use distilled or bottled water when mixing hydrostone. Always use a mask, safety glasses, and gloves. Once the hydrostone is a thick, syrup-like consistency, you may add the natural dye. For consistent color between pours, mix the dye into the hydrostone powder prior to beginning the project. After inserting the tube, pour the hydrostone into the bottom of the dish, no more than a few millimeters deep. Ensure the tube is not touching the plastic. Once the hydrostone has set, insert the stopper. Place the dish on a small piece of clay or another object that will create a slight incline. This will make a deep and shallow portion of the nest, which will give the ants more freedom to position their brood. Moisturize the existing hydrostone to ensure a good bond. Pour the new hydrostone until it covers the tube. Pour a drop of plaster onto some plastic wrap. I'll show you why this is important later on. As the plaster sets up, you may use a spoon to create depressions in the plaster for the ants to use. If you would like to embed substrate into the stone, lightly press it in. You can also add loose substrate when the stone is hardened. Once the hydrostone has cured, remove the tube and stopper and allow it to dry for a few hours. Next, use a hot glue gun with waterproof hot glue or aquarium-safe silicone to attach the hydration ports. The holes should be sealed. Position the hydration ports such that they will hold the lid in place, but not so tightly that the lid can't be removed. If you are using a friction-fitting lid, this step is not necessary. Optionally, you can heat a metal pin with a flame and use it to create ventilation holes. This can be useful if you plan on heating the nest or if you will be keeping a large colony in the environment. Keep in mind that vented dishes or ventilation holes are not compatible with tiny ants such as Monomorium or Solenopsis molesta. We have completed a laboratory-style Petri dish Formicarium. These simple formicaria are linkable to other dish nests, outworlds, or test tubes, and they can be arranged any way you like. To hydrate the Formicarium, simply fill the hydration tube until water is visible on the other end. To check the moisture of the dish, use the small tester piece you created earlier. If the plaster matches, it's time to hydrate the nest. I've designed this Formicarium to be easy to use, cheap to make, and effective for most ant species. I hope you found this tutorial helpful. If you have any questions, let us know down in the comments. And if you enjoyed this video and want to see more content like it, please like, subscribe, and share it with your friends. It helps us immensely. Thanks for watching.